This was the historic moment when NASA's OSIRIS-REx successfully delivered the sample of asteroid Bennu to Earth, dropping it off to be collected in the Utah desert. Now that the material has reached Earth, what's next? IFL Science spoke to some of the people in the OSIRIS-REx sample analysis team to find out how this precious cargo will be distributed to laboratories around the world.
For our samples, we're going to hand carry them, so either me or a colleague will go over and collect them from the Johnson Space Center, probably. But the Johnson Space Center are also happy to send them by courier as well. And actually we went through we had to rehearse this. So everything in this mission is so well rehearsed. So they've rehearsed it landing, they've rehearsed it going into the curation facility. Another thing they've rehearsed is sending the sample around to the different labs. So we had to go through this exercise. Well, we had a pretend sample and somebody said, I've sent this sample to you, here's the packing label. And then a few days later you had to write, yes, I've received the sample and here's a picture of it, what it looks like now. So every stage it gets photographed, everything that happens to it gets documented, like who sent it, like who's kind of responsible for it, and everything is written down and everything is rehearsed. And yeah, so the curator knows exactly where every tiny fragment is at all times.
So the sample's journey has not ended just because it reached Earth. When it gets to its final destination, what do scientists hope to discover?
My interest in particular is physical properties, density and porosity. So density is the mass divided by volume, and porosity is how much pore space. And we have a general idea of those properties for the asteroid as a whole from when OSIRIS-REx visited, but when we can compare it with the actual specimens we have in the laboratory, we can get some better idea of the overall structure of the asteroid. The amount of pore space in the whole asteroid versus the amount of pore space in the rock will tell us how much empty space there is between the rocks in the asteroid, which will help us to understand better how it's put together and help constrain our models of how it formed.
First sample we'll get will be a little vial of tiny little bits of powder, and we'll pick out bits from that and we will CT scan them. So we'll be able to look at the structure of them and get an idea of its composition. Then we'll put it in an electron microscope, which will enable us to do some element mapping. So we'll see what elements are in there, and that will tell us what minerals we're looking at. And we'll do some X-ray diffraction, which looks at the crystal structure. So again, that will tell us about the mineralogy. And then we will get a polished surface, which will enable us to get much more precise element abundances and chemistry, and ultimately trace elements as well. And all of that will kind of give us this picture of what kind of object it is. So at the end of that, we'll be able to say whether it's like any known meteorite or if it's something completely different.
From the surface of Bennu to the Utah desert and onward to research institutions around the world, there's much to learn from this highly anticipated asteroid sample. Now, the primary mission of OSIRIS-REx has concluded, but this is not the end. The spacecraft will continue to fly into the cosmos towards a new target. It will be called OSIRIS-APEX and will study NASA's next big target, asteroid Apophis.